Okay, welcome to the first video for section 6.7. This is the last section of chapter 6. So we're going to be using all of the material that we've learned so far and putting it all together to look at identifying some different graphs and also doing some real life word problems that involve exponential functions and logarithms. So first, we're going to look at some data tables, and we're going to identify what types of functions are represented by the data in each table. So first, let's look at part A right here. Now, before we can look for patterns or information that we can pull from our values, we need to see that this data is equally spaced out. If we're not looking at data that is spaced out at equal intervals in our graph, then we can't really make any conclusions from that data. So the first thing you want to check is you want to look at your x values and you want to see that they're equally spaced out. So we see that in each of these, this is plus 1, this is plus 1 right here. So we're going from -2 to -1, -1 to 0, 0 to 1, that's plus 1, 1 to 2, 3 to 4, and 3 to 4, and so on. You see that these are all plus 1. So that means it's evenly spaced out. So now, once it's evenly spaced out, we want to look at our y values and see what patterns we see in our y values. So let's look at the output. We go from 0.5 to 1, 1 to 2, 2 to 4, 4 to 8, 8 to 16, and 16 to 32. So we see that those are all being multiplied by 2 each time. So when you have an output that is being multiplied by a constant value, that means that it is called a common ratio. So our y values have a common ratio of 2. When you have a common ratio, this means that you are looking at an exponential function. So right here, we see that every time we move 1 in our x direction, our y value is increasing by a multiple of 2. Okay, so again, this is called our common ratio. So a common ratio is a constant multiplier when your y values are evenly spaced out, and that means that we have an exponential function. Okay, so that's how to identify an exponential function. You look for a common ratio over evenly spaced out points. For part B, we've got a table here, and again, first thing you want to do is check out that your x values are evenly spaced apart. So in this case, we're going up by -2 to 0 is 2, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. We don't always have to be spaced out by 1 unit. As long as we have an equally spaced data set, then we can look for patterns in our y values. So in this case, since we are equally spaced in our x points, we can look for patterns in our y values. Now, 2 to 0 to 2 to 8, 18, 1832, 3250, this does not have a common ratio, right? 2 times 0 is 0. 0 times 2 we can't get to. 2 times 8, 2 times 4 is 8. 8 times 2.1 something is 18. So again, there's no common ratio. So what we want to do is analyze the finite differences. Now we've done finite differences before. We did finite differences when we looked at linear versus quadratic versus polynomial. So what we're doing with finite differences is we're seeing the difference between each successive y value. So the difference from 2 to 0 right here is -2. The difference from 0 to 2 is +2. The difference from 2 to 8 is 6. The difference from 8 to 18 is 10. The difference from 18 to 32 is 14. And the difference from 32 to 50 is 18. Okay, now when you're looking at these differences, we're trying to find at what level do we have a common difference. and then that tells us what type of function we're looking at. Now, you see, this is called, right here, this is called our first difference. Right now, if our first difference was constant, was just a constant number, then that means we'd have a linear function. So your first difference tells you if it's linear or not. And again, if it was a constant value, that means it's linear. But this isn't constant, so we have to look at our next difference, which is called our second difference. So now we're going to go from -2 to 2. That gives us 4. If we go from 2 to 6, that's 4. If we go from 6 to 10, that's 4. So you can start to see this pattern here. 10 to 14, that's 4. And 14 to 18, that's 4. This is what's called a common difference. Common difference. In this case, our common difference is 4. Sorry, my pen's getting a little out of control. Common difference. Now in this case, because it's our second difference, first we did not find a constant. Our second difference, we did find a constant. Because we found a constant in our second difference, it means this is a second degree function. Second degree function is a quadratic. So here's a nice chart for you to look at. So you can look at the differences that we found right here. Again, our first difference was not constant, so it didn't tell us anything. We found our second difference, which was constant, which tells us that it's a quadratic. Now, if these numbers in our second difference weren't constant, we would use those values to find our third difference to see if it was a cubic function. If not, check to see if it's fourth. These are called finite differences. We keep taking the next level difference until we find a constant, which tells us what type of function we're looking at. Okay, so that's how you can look at data sets and tell either if they're exponential or what type of function they are by looking at the differences. So again, if it's a common ratio, then it's exponential. If they have a common difference, depending on what level of difference they are, you can tell what type of function. What I want you to answer right now, I want you to look at these two types of functions represented by the tables, and I want you to do the same thing. I want you to tell me both what type of function it is and either what the ratio is or the difference. So in the text box you should have two parts to each answer. For part A, I want to know what type of function and how you learn that, so what the common difference or common ratio is. And then for part B, what type of function and what the common difference or common ratio it is.